In this video, I'm going to focus on the basics of vectors, the definitions, and all the calculations and facts you need to know about vectors. So vectors you've seen before in other subjects, say in physics. They are quantities, but they are special quantities because they have a direction. So for example, you've seen it as displacement. So I could tell you that I have a distance for something, and the distance could go anywhere, but displacement is more specific because it tells you which direction. So if a displacement graph goes upwards, it means I'm moving away from where I started, I'm straight, and then I'm moving back to where I started. So the direction of where this arrow goes matters. Another type of vector you've seen before is velocity. So when you talk about speed, you just talk about how much the distance changes over time. But then when you talk about velocity, it's still speed, but on a direction. So if I'm throwing a ball upwards, I could give it a positive velocity, but then when it comes downwards, I'll give it a negative velocity based on the direction it's going. So you've seen these type of things where you have a quantity, but not only does it have a quantity, it has a direction. So these are called vectors. And we want to formally define them. And there are different ways of defining a vector. So I could represent them as a letter. So I could write A, and because I'm writing it, I'll write A with a line underneath, or an A with a squiggly line. And in exams, you'll see vectors with a bold font, so they'll go more for this type of thing. So this is representing a vector. So this is a quantity, but it also has a direction. I can also use a column vectors, also called component form, which is using this kind of column thing, and I could say 2 and -5. And what the 2 and -5 represent are your typical x and y direction if you're thinking like the axes. So this is move 2 units to the right, and this is move 5 units down. So you've seen something similar in this, say, in transformations or so. As a line, I could represent this as, well, I'm moving 2 units to the right, 5 units down. It could be something like this. So on a graph paper, you might see it moving 2 units down, and then 2 units to the right and 5 units down. So notice how the arrow matters. I could also represent it as a point, moving between points. So let's say this is my point A and point B. So this vector, instead of representing it as one letter, I could say, well, it's the vector that moves from A to B, and it has to go from the direction of A to B. So this is my vector. So this is 2 units to the right, and then 3, 4, 5 units down. So quite straightforward how we represent it, but keep in mind in exams, this is what the representation looks like. So this is basically the definition of vectors, and we will use arrows to represent them, and the direction of the arrow matters. An interesting part in vectors is to calculate what we call the magnitude. So I want to know how much did I move actually in that specific direction. So instead of thinking about it as components, so as x and y, I want to know how much was my movement. So if you look at this, let's say I had this, and let's say it was a -7 and 4. So I moved -7 to the left and then 4 upwards. I want to know how long did I move, and hopefully you can see that I can form a right angle triangle from this. So I moved 7 units backwards and 4 units upwards. And you can use Pythagoras to find the length of this. So to find the magnitude of vectors, you can either memorize the formula or think about it as Pythagoras. So the magnitude, let's say this was vector A, the magnitude is represented by a bar around your letter. So these bars tell you that I want the magnitude, and the magnitude is just the square root of your numbers, the square of your numbers summed together and then square rooted. So this will give me the square root of 65, which is 8.1, and that's to 1 decimal place. So that's a good way of finding how far did you move and not worrying about the direction, just am I moving upwards, downwards, and so on. So this is magnitude. If this vector was an A to B, say, vector, then my magnitude will be written as such, and again the answer is 8.1. And if you really want the units, you can just write units. And then we move on to an important part, which is the calculation. So we want to be able to multiply scalars, add scalars, subtract scalars, and so on. Multiplying them, we won't go through the complex multiplication. We'll do simple scalar multiplication, and adding and subtracting them are straightforward. So a scalar multiplication of a vector just means that you're increasing it by that amount. Think about it as a scale factor. So if I have this as my, let's say, A, and if I am going to multiply A by 2, it means I have 2 of this. So this will be my A, and then so I'd have my A, and I'm representing it twice. So this will be my 2A. So I'm multiplying A. So I have 2 lots of A, so it's doubling up. So if this was a column vector, say I had an example, I could have 1 and 3. And I'm doubling this 1 and 3. It means this new vector, this 2A, is equal to just me spreading this 2 out to each one because I'm doubling my direction. And so it would be 2 and 6. Obviously, this is a straight line, and this is not a straight line vector, but just an example of what happens. And if you have say a negative scalar, so let's say this is my B vector, and I multiplied by a negative B, or let's say a negative 3B. Not only will it triple in size, so if this is my original B, but I have 3 lots of it. Not only will it triple in size, but it will also move in the opposite direction because of the negative. So negatives, it's the opposite direction. So we are discussing scalar. So for example, if B was 5 and 2, and I'm multiplying it by 3, so my new negative 3B will be negative 15 and negative 6. So in general, a negative multiplied by our vector will move it in the opposite direction. But this is what we call scalar multiplication. You're multiplying by a number. Next we have addition and subtraction, which are quite straightforward. They're not impossible to do. So for addition, if I have, say, a vector A plus a vector B, what you're going to do is add them component-wise. What do I mean by component-wise? I mean just the letters X and Y. So if I have, say this was 3, negative 1, and I'm adding it to 5 and 3, then I'm going to add 3 and 5, so I'll have 8. and 3 and negative 1, so I'll have a 2. So you're just going to add them across. So across here. Now, what does this actually look like? If I have a diagram, let's say my 3, negative 1 is something like this. So this is my A, because I'm moving 3 across and 1 down. And then my B is 5 across and 3 up. So let's say this is B. And what I'm doing, why did I put them next to each other, is because what this is telling me is that I'm moving at A and then I'm moving with B. So this is giving me a movement, because remember, vector gives you direction as well. So basically what I just did was move from here to here. So this is the result of doing A plus B. So this is what 8 and 2 looks like. This is the result of going A to B. Now, I could either go, if you think about it in real life situations, you can either move A and then plus B, or you can move 8 across and 2 above. So a more straightforward movement. So sometimes it's useful to know what the diagram looks like in this situation. And we will be dealing with this type of thing where you have to move from one point to another. So if I name these points P, Q, R, I might ask you, I need to move from P to R. Well, in order to move from P to R, you have to move across through A and then through B. This will be done in another video, but just to show you what it actually looks like. Now, if I actually use the same letters, the same vectors, and I do the opposite, so I'm going A and then I'm going negative B. So I'm not going upwards now, I'm going the opposite direction. So and negative B would be a negative of the vector itself, and the vector itself is 5, 3. Okay, so negative 5, 3 would mean I am moving downward, to the left by 5 and down by 3. So to the left by 5 and down by 3. Okay, and then I will have moved from here to here. So this is A, but minus B. And again, the way to do it is straightforward, just like component-wise. So I have 3, negative 1. But this time what we did, we took the negative of B. Or we can add this instead, which would be the same thing. So negative 5, 3, not using this. The reason I did this on the side is just to show you what happens. We're moving 5 backwards and 3 downwards. But if you want to know the final results of what you're going to do, just use the original and just put the negative or whatever scalar. It might be negative 2b as well, so you have to use the same concept. And then 3 minus 5 would just be negative 2, and negative 1 minus 3 will be negative 4. So I'm moving to the left by 2 and down by 4, which makes sense with this diagram. So again, adding, subtracting, so this is subtraction. Missed out on the spelling. So this is subtracting vectors, and quite straightforward to do. So these are the main facts you need to know about vectors calculation so far. So scalar addition and subtraction. And just a few things to point out. One more thing is parallel vectors. Two vectors are parallel if they're scalar multiples of each other. So two lines are parallel if we don't touch, and this is a given fact. So if this is my, let's draw actual straight lines. If I have this as a line, and then let's say this as a line. Let's assume they are parallel. They're not quite, but let's assume they are. So they never meet in this case, and we say that they are scalar multiples of each other. So let's say this is A, and let's say this is B. And let's say A was -3 and -2. And B was -9 and -6. Okay, so if you notice that B is actually a multiple of A, because B is basically just 3 times A. Okay, so B is basically 3 times A. And when you have this property, then the two vectors that you have are parallel. They're parallel, they will never meet, and they're just moving at the same direction, same quantity. It's just one is a multiple of the other. Not the same quantity, but not the same magnitude, but same direction. So this is the point on parallel vectors. So you need to use all these facts on vectors that we've done just now to be able to solve any vector-related question, and this will especially help you for vector geometry, which is in another video.